Welcome. I have a quick update for you. I would like it if you were able to do some checking with inequalities. So this long inequality in one variable, I've already solved it. I encourage you to go do that on your own and see if you come up with a final solution for this one of x being less than or equal to 7/10. So when I did it, I come up with x is less than or equal to 7/10, and I made my picture, and off I go. But I'd like to be able to check this, so at least I have an idea of whether things are working or not. If I check the point x equals 7/10 in the equality, 3x minus 2 times the quantity 4x plus 1 equals 5x minus 9. If I plug x equals 7/10 in here into equality, it should work. It should give us a true statement because 7/10 is that breaking point, that boundary point where things change from solutions to non-solutions. So let's see if that works. We would plug in 3 times 7/10 minus 2 times the quantity 4 times 7/10 plus 1. And we need to see if that's equal to 5 times 7/10 minus 9. And you can feed this left-hand side of the equation into your calculator and the right-hand side into your calculator. And when you do that, I think you'll get that negative 5.5 is equal to negative 5.5. You get a true statement here. So that means that your boundary point that you found is accurate. But now what about this shading? This left-hand side of the graph versus the right-hand side of the graph, or the number line. What we do for that is we pick a point that is less than our boundary point. So I'm going to pick x equals 0 as a test point. 0 is friendly. And I'm going to test it. Test x equals 0. And I'm going to test that in the inequality. So I will come up to the very top equation, and I'll do 3 times 0 minus 2 times the quantity 4 times 0 plus 1. And I'd like to know if that's bigger than or equal to 5 times 0 minus 9. And I need to work out the left-hand side and the right-hand side of this inequality. 0 minus 9 is negative 9. Over here, we'll get a 0 in the beginning, and then we'll get negative 2 times positive 1. So we get negative 2 is greater than or equal to negative 9. And this is true. That's good news, because I just picked a test point in the solution area, and it came up true. That means that I have shaded things correctly. Let's see what happens when we test something on the other side in the non-solution region. So maybe over there, maybe I choose x equals 2. Again, I go to the very original inequality that I was given, and I would do 3 times 2 minus 2 times the quantity 4 times 2 plus another 1. And I'm wondering if that is greater than or equal to 5 times 2 minus 9. When I work on this, I'll get 6 minus 2 times 9 right here. On this side, I'll get 10 minus 9, which is 1. A little bit more work here. 6 minus 18 is negative 12. So my final statement when I'm testing x equals 2 turns out to be false. And that might seem like it's a bad thing, but it's not. My test point of x equals 2 was in the region that I did not want to have as part of my solution. It is not part of the solution set for this problem, so it is not working in the original equation. And that is how we can test our work for inequalities. We can test the boundary point to see if it gives equality exactly. We can test points in the solution region to see if they make true statements from our original inequality. And we can test points that are not in the solution region to see if they make false statements in the original inequality. So I hope that helps you check your inequality work.